Good morning, everyone, and thank you for waiting. Welcome to the May edition of the Southeast Climate Monthly webinar, where we talk about the climate and special topics pertaining to the Southeast region. I'm Sandra Rain, the Regional Climatologist from the Southeast Regional Climate Center, and I will be giving a climate overview. Our guest speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, Pam Knox from the University of Georgia, who will give an agricultural impact update, and our special topic speaker, William Sweet from NOAA's Ocean Service, who will be talking about updated sea level projections. We thank everyone for joining us. Just a reminder before we begin to type your questions in the question box at any time, and they will be answered at the end. Also, an email with a YouTube link to this recording, as well as a link to the summary of today's webinar, will be sent out in the next day or two. Okay, let's talk about the climate. Temperatures over the past 30 days have been near average across most of the region, although Tampa, Florida did have its third warmest April on record. Precipitation over the past 30 days has been below average across much of the region, depending on where the storms came through. Monthly precipitation totals range from 70 to less than 25% of normal in parts of Florida, Georgia, and the Carolinas. As we continue on through the spring and see more thunderstorms popping up, the probability of severe weather will continue to increase over the Southeast region over the next month. As a matter of fact, we had a severe weather outbreak April 5th and 6th that included about 62 tornadoes. Bryan County, Georgia had an EF4 tornado with winds of 185 miles per hour. Unfortunately, there was one fatality and 12 injuries with this tornado. It is interesting to note that this is only the 11th EF4 tornado in the entire state of Georgia since 1950. Moving on to the ENSO update, we are still under a La Niña advisory, with a 59% chance of La Niña continuing from June through August and a 50 to 55% chance of a La Niña through the fall. So there is a possibility that we may see our third La Niña in a row this coming winter. The next update comes out this Thursday, May 12th. The U.S. Drought Monitor continues to show some exceptional drought in the western part of the United States and southward into parts of Texas. And the outlook has drought continuing in the west, which will continue to exacerbate the water issues. Here in the southeast, drought conditions remained relatively the same, with a pocket of severe drought in eastern North Carolina and moderate drought stretching down into Georgia. Southern Florida also has moderate drought with pockets of severe drought conditions. It is also beginning to dry out in Virginia as well. The Caribbean is dry with moderate drought seen across a small part of southern Puerto Rico and moderate to severe drought across parts of the Virgin Islands. The Lawn and Garden Index also shows the dry conditions across the southeast. And unfortunately, the drought is expected to persist in Georgia and South Carolina, but hopefully it will improve in North Carolina and Florida. For the next 3 months, we have the probability of seeing above normal temperatures across the region, with the probability of wetter conditions in Virginia and Florida, and equal chances of wetter or drier conditions across the rest of the southeast. For the 6 to 10 day outlook from May 14th through 18th, there is a probability of above average temperatures for the region, as well as a probability of above average precipitation for most of the southeast. And speaking of precipitation, we should see some by the end of this week. The heaviest amounts will probably occur Friday and Saturday, especially in North Carolina and Virginia, which hopefully will help ease some of those drought conditions. And hurricane season is just on the horizon. Although the official start to the season is June 1st, the National Hurricane Center will begin issuing outlooks on May 15th. The National Hurricane Center has not yet given its official predictions, but Colorado State University and the Weather Company are suggesting it will be an above-average season. Be sure to join us next month on June 28th, where we will have Matthew Rosenkrantz from the Climate Prediction Center talk about the 2022 hurricane outlook. Okay, to sum up, the Southeast has had near average temperatures for the past 30 days. Precipitation has been below average. Severe weather chances are increasing, and Georgia has had its 11th EF4 tornado. We continue to be under a La Niña advisory, and the new update comes out this Thursday. Drought is observed in the eastern Carolinas, Georgia, and Florida, and is expected to persist. Precipitation is likely by the end of this week, and the next 3 months will likely be warmer than normal, with equal chances of wetter or drier conditions. And now I'll throw it over to Jeff Dober with the River Forecast Center.
Okay, thank you, Sandra. So Sandra gave a good rundown there of the weather and climate, and now we're going to lead that right into the stream flow. And we'll talk about our summer flood outlook as well. So here's the latest 28-day average stream flow map from our partners at the U.S. Geological Survey. That's on the left there. And you can see for the most part, near normal stream flows across most of the Southeast region. The exception there being that eastern part of North Carolina and Southern Virginia, where, as Sandra pointed out, we have some severe drought going on. As far as the duration hydrograph there, you see stream flows typically fall off this time of year with the green up and a little bit less rainfall during the late spring across most of the region. And the black line there, that is the observed runoff, or what represents stream flow across the region. And you can see that tracking well into the green there. And we've been sort of near normal really since the month of March in that green area. But we do see stream flows declining, which is normal. And now we break that down state by state onto the next slide. We see pretty much the same here. In Alabama, we saw us sort of treading for most of the late winter and early spring, right near the above average to near normal range. And now we're sort of falling off here during the month of April and May in Alabama. And we see that same signal in Georgia, as well as in the state of Florida. As we work east into the Carolinas, we see South Carolina here in the normal range, North Carolina treading just in that normal range to maybe slightly into the below normal range right now as far as overall for the entire state. And we see that as well for the state of Virginia. Going on to the next slide, we see here's our local conditions. And right now we have no minor flooding across the entire Southeast region. And this is pretty typical for this time of year. So no flooding going on here or in Puerto Rico. Next slide. And we'll show you what's typical. So here's the river flood climatology, looking at 103 select forecast points across the Southeast region. And we're in week 19. And so we've really come off that, we really have come out of our river flood season. And now we're sort of in a quiet time of year as a region as a whole. And this sort of lasts into the early summer period. But there are exceptions. If we go to the next slide here, one exception is our South Florida group. This would be like our Tampa area, Tampa area rivers, St. John's River, and those river systems in the Florida Peninsula. This is over the next several weeks, we'll start to see their wet season begin, and that sort of starts their uptick of their river flood climatology season. So again, we're in week 19, and you can see that uptick doesn't really start for another 4 or 5 weeks. And we're looking at maybe late June into July. And so for the most part, for the most part across the Southeast, river flooding is not common during the next 4 or 5 weeks across most of the region. And then we'll see an uptick in the Florida Peninsula. We'll go on to the next slide and we'll talk a little bit more about this. As far as our river flood outlook for the summer, May, June, July period, we're talking about normal, near normal risk of river flooding. So for the interior Southeast, that really is a low seasonal risk, as I was saying. But for the Florida Peninsula, this is their typical time for river flooding, especially around the Tampa area. This is when their wet season begins. And so river flooding, especially minor, scattered minor flooding, is common as we go into late June and July. So that is the river flood outlook. So in summary, right now, stream flows mainly near normal across most of the Southeast, with the exception being North Carolina and Southern Virginia, where we are seeing some of those drought conditions and below normal stream flows. Stream flows typically fall off this time of year, the exception being the Florida Peninsula. And as far as the expectations, those stream flows will probably continue to be in the normal range for most of the Southeast through the summer. Flooding for this early summer period will be typical, which means a low chance for the interior Southeast, though an increased risk, especially as we head into late June and July for the Florida Peninsula. And of course, there's always the risk of tropical systems as we get into the month of July. So that's all I had, and I will pass it on to Pam.
All right. Thank you, Jeff. It's a beautiful day out today here. There's not a cloud in the sky in Athens, and I think in a lot of the region this morning, so we can expect to see some more of that this week. Let's jump right on in and look at some of the impacts of recent conditions on agriculture. The dry conditions have been around for the last few days. As Sandra pointed out, we haven't had a whole lot of precipitation. That has been really good for things like making hay, and a lot of the first cut hay has already occurred, but it has been a little bit detrimental to people who are trying to plant, because if you don't have moisture, it's hard to get those seeds to germinate. And so there's a delay in planting of many crops like cotton and peanuts, just because they're a little hesitant to put the seed in the ground if it's just going to sit there and not really do anything. So that's something to keep in mind. The onion harvest this year in Georgia, of course, we're known for our Vidalia onions, and that has been doing really well. They had some problems with some of the leaves early in the season, but the harvest is well underway and has done really well. By comparison, our blueberries here in Georgia have not done well. We had several frosts this spring, and those frosts, the first frost hit the early blooming varieties, and the later frost hit the later blooming varieties. And so they've had a lot of problems with gold damage. The picture of the blueberry on the left-hand side there shows sort of a corky damage that occurs inside the berries when they have cold damage. Some of the other things are like misshapen berries, and those are the ones that kind of half froze and didn't fall off the bushes. And so that's certainly reducing the quality of the blueberries this year. And the result is in the last National Ag Statistics Service newsletter, they listed over 60% of blueberries in Georgia as poor or very poor due to those spring frosts. There's still quite a few there. We're not going to run out or anything. And there's blueberries, of course, in Florida and South Carolina and other places as well. In spite of the dry conditions, pasture and forage has been doing well, but we are getting dry areas, and I can tell that because I'm getting phone calls from people who are worried about the forage running out, and they're still feeding a little bit of hay, I think. So that's something that's been of concern. But so far, generally livestock is in good condition, and the pastures are in pretty good condition in most places. Let's go on. This is my last frost slide of the spring. I'll start again in the fall when it gets to be that time of year. But over the last couple of weeks, the only places that really had frost were mostly the higher elevations in the mountains in North Carolina. And then as you go north in the region as well, they've had some frost as well. So we're pretty much out of the frost season for most areas now. So I won't be covering that until we get into fall again. But definitely had some problems with the frost this year for agriculture. And let's go on. these are some little different views of soil temperature and moisture. Um, on the left, it shows the departure from average soil temperature conditions across the region. And you can see that a lot of the southeast has been having soil temperatures that have been warmer than normal. And so that has really allowed the farmers to catch up a lot on planting, except for the fact that it's also dry, as you can see in the right-hand um, map there. The dry conditions have slowed things down, but they're raring to go. And so, as soon as there's enough moisture in there, or if they've got irrigation, they can of course irrigate the soils, and that can help as well. Um, but the warm conditions have really made the crops that are in the ground and developing very rapidly. So that's been really good for the crops that are already in. It's the ones that have not yet been planted that are more of an issue.
Hello?
We go on. One thing I did want to mention was that, I got these phone calls about dry conditions by a lot of the forage producers. There is a way to monitor that and to report your reports called condition monitoring reports, or they like to call it CMOR. Reports. This kind of replaces some of the older drought impact reporting, although those are still active as well. And you can see there hasn't been a whole lot of reports in the southeast so far. There is one down. I put the map in here to show that there is one in Puerto Rico, in the dry area there, but not a lot in the southeast so far. I cut off the top of the map, but there's a huge number up in Montana right now. And if you want to go and put in a report, you can talk about what you're seeing. You can also report flood conditions if it comes to that. And so you can put in your report. You talk about how long you've been farming or how long you've been in that area, and put that in, and that will pop up on this map. And that really helps the drought monitor authors to know. It's like having eyes on the ground, so they can actually see through your eyes what's going on. And that's very helpful to them. Of course, they have lots of other things they look at as well. So you're probably not going to make or break the drought monitor, but it certainly is helpful information to them. And so if we go on, the next couple weeks, Sandra's talked about this a little bit already, as Jeff has as well. The next couple weeks look like they're going to be relatively dry across a lot of the region. The one place where it probably won't is in the Carolinas, where we have this low that developed as the front pushed through earlier in the week, or late last week, I guess. That low is sitting out really just beyond where the radars can see it in the Atlantic Ocean, but it's supposed to continue to drift south and west, and it's supposed to come onshore probably around the area of Savannah by next weekend. It's not going to be, I don't even know if it's going to be a named storm, but it is going to bring some rain to the area, especially where there's onshore flow. But that's really the main rainmaker for the next couple weeks. We do see that the 8 to 14 day temperature outlook does show that we're likely to continue to be warmer than normal. Not surprising if we've got sunny skies and dry conditions. It's going to be pretty easy to have those temperatures warm up. And just a mention that some of the longer range models are showing some signs of tropical activity along the East Coast late in the month. The long range models are notorious for putting out a lot of these storms that never amount to anything. So you got to kind of keep that with a grain of salt. But you do need to keep in mind, this is a great time for you to be preparing ahead of time for whatever tropical activity comes, and it's likely to be a pretty active season. Now, whether those come to the southeast or not, of course, is still an open question. But doing things like making sure you've got fuel for generators if you need it. I know it's expensive, but you got to have some. Keeping an inventory of equipment, all those kind of things that you get too busy to do later in the season, and it's a really good time to do that now. So just keep that in mind. It's going to pick up. The last few years, we've had tropical named storms in May almost every year for the last few years, and so it would not be surprising if that happened. If we go on, I think that's my summary slide. Yes. We have had warm and dry weather the last few weeks, and that's really helped with hay, but has hampered the planting of crops like cotton and peanuts that need some moisture in the soil. Farmers that have irrigation are running it pretty wide open right now. Cold damage to the blueberries is becoming pretty evident in the Georgia harvest from the last frost and earlier in spring. The dry conditions have reduced a lot of diseases. Now, it hasn't eliminated them for sure, but it's reduced them. But it has increased the activity of damaging insects, and so that's something that farmers are really having to watch carefully. Next 2 weeks do look warmer and drier than normal, and so I would not be at all surprised if the drought monitor did expand the drought conditions, at least in the short term. Now, whether or not that happens over the long term, of course, is an open question. But just something to keep in mind. I don't think we're going to go back into really wet conditions anytime in the next couple weeks. And just a reminder that the tropics are starting to wake up, so you need to prepare if you haven't already. And that's all I've got, and I will pass it. Am I passing it to Meredith or Sandra or right to William? Billy, I don't know which.
I'll be happy to actually take it from here. Thank you so much, Pam. My name is Meredith Muth. I'm going to pass it on to our special guest, which will be William Sweet. William I'm going to go ahead and make you the presenter.
All right. Let me know when you can see the slides.
We can see it. Thanks.
Great, thank you. All right, well, I'll jump right into it. Today, I'm going to do a quick presentation on the latest set of sea level rise scenarios and extreme water level probabilities put out by the Interagency Sea Level Rise Task Force. Okay, sea level rise. We've had about 1 foot or 0.3 meters of rise on average along the continental U.S. Shoreline, based upon sort of a spatially weighted average of United States tide gauges. You can see that the rate is actually picking up over the last 50 years. And the question is, where is it headed? Where is it going? So that's where we step in. The 2022 Interagency Sea Level Rise Report is a report building upon a former series. We had a report in 2017. There was an assessment done for the military in 2016. It built upon interagency group in 2012, sort of in line as best possible the national climate assessments and the interpanel panel for climate for the IPCC. Excuse me, that's just a mouthful right now. But it's for the United States, and it's based to the focus is really to kind of make an assessment as to what's going along the United States coastline, what's been happening, where we're going, what could we expect. So in particular, how much rise could we have by 2050? This is a little bit different than years past, where we now are speaking with a little bit more clarity and consensus as to what to expect. But how bad could it be? How much rise could we have at 2100 or 2150? And then to translate that and contextualize that, what does that mean for actually impacts, let's say of 2 or 3 or 4 foot water level above average high tide, which I'll speak to later about how that aligns with Weather Service actionable thresholds that we use in day-to-day decision making. Typically disruptive about 2 feet, typically damaging about 3 feet, and often destructive when you get about 4 feet above average high tide. What is that risk now, and what is that risk likely to be by 2050 under today's flood defenses and footprint? Okay, so scenarios. In this report, the scenarios were largely building upon AR5, the last set of modeling from the IPCC assessments. The scenarios range from 0.3 to 2 meters, and they are based upon differing warming and emission pathways. So what I mean by that is, excuse me, AR6 models. What I mean by that is that generally lower emissions and lower heating would end up with less sea level rise. And so the models are all trained upon future amount of warming. And that warming then translates typically in these societal pathways, but now directly looking at saying, okay, if we warm by 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees C compared to pre-industrial, what is the likely outcome? And what you can see in this takeaway is that the scenarios that follow suit from the last go round of 0.3, 0.51, 1.52 meter rise globally by 2100 is sort of how the designation of them are still occurring. The 2.5 extreme scenario globally is, we took that off the table. It seems less likely than it even did last go round based upon the updated ice sheet modeling. But in essence, we are likely to see the low and intermediate low under lower emissions, lower warming. That's sort of the trajectory that will take us there. As we get to the higher scenarios, it requires higher emissions and higher warming. And to get to, let's say, the intermediate, high and intermediate, it also takes some known unknowns. The less confident ice sheet responses that aren't very well parameterized in the modeling themselves, typically using sort of the expert elicitation, sort of, what is the best judgment as to what we know and is not characterized in the models, but what could happen. Because if it could, it might, and if it might, we need to know about it, and we need to express this in some quantifiable way to decision makers. Let's see, I'm not advancing. Oh, okay. So here's what the sea level rise scenarios look like for for CONUS, the contiguous US, sort of on average. The black there shows the tide gauges with the fit shown in green that is extrapolated out 30 years. So we are relying on the observations now. And what we see is the characterization, the extension, if you will, of the observations are squarely landing within the range of the scenarios themselves. These forced scenarios of 0.3 to 2 meters by 2100, they don't diverge much in the next 30 years. And that gives us greater confidence, sort of 2 lines of evidence. The models obviously are calibrated to the observations, but then they are run and they're mostly independent from the observations themselves. So 2 lines of evidence giving us more confidence to more clearly say what to expect next 30 years. And what that is about a foot of rise in the next 30 years, which would equal the amount experienced over the last 100. So again, the models and the observations align not only at a national scale, but we also see that when we break down within regions, the Northeast, Southeast, Eastern Gulf, Western Gulf, and so forth. So here are the numbers as they are expected, the amount of rise expected, and that expectancy is largely an assessment, but it's pulling off where the trajectories themselves are going in consideration with the scenarios themselves. So on first order, this is what we would expect the amount of rise to be in the next 30 years. So again, higher in the Gulf for some reasons we'll look at, but this is now being supplied. So, and even down to a local level, so folks can really get a better sense of, what at a minimum should they expect in the next 30 years for decision making to better manage risk. We know these scenarios differ geographically. It's not like water rising in a bathtub. We have higher rise on the East Coast than the West Coast in general because of largely due to heating, warmer, sort of the stereodynamic or the heating and circulatory processes that would show a continuation largely of what we've been experiencing over the last several decades of higher rise rates. Factored into that would be land subsidence for natural and or unnatural reasons, unnatural being extraction of groundwater and fossil fuels for consumption, natural being compaction of sediments, adjustment from the last ice age. The observations and models both agree in this regional representation of the rise. Also important is where ice melts matters due to gravitational and deformational effects, not so much in the next 30 years, but in 2100 and beyond, and at the higher scenarios, that definitely comes into play. Here's what the scenarios look like, extending out to 2150. Again, even the lower scenarios really start to add up But the higher scenarios, again, are largely in response to future emissions, and then the way the ice sheets themselves will respond to these higher emissions, higher ocean and atmospheric warming. It's really the impacts, though, that are important. Mean sea level isn't itself what is affecting folks. It is the elevation of tides and storms and the things that cause the water to move around at higher frequencies that are impacting. And that's really what the second part of the report was focused, is how to characterize and let's graduate sort of the flood risk or probabilities within FEMA's floodplain. For context, we know that minor high tide flooding, and we'll define a high tide flood, what that means momentarily, is twice as likely as it was 20 years ago. We know because of sea level rise, very clear signal to noise, the average rate of high tide flooding has doubled in the last 20 years. And that rate is accelerating on an annual basis. On a year-to-year basis, it is accelerating, and that is the case in most East and Gulf coastlines. So up to about that 2 foot above mean high water is the region that we are referring to in these statistics. Shown here on a national scale, again, just a large sort of wrapper to say nationally, what does that look like? That same 1 foot of sea level rise, or 0.3 meters, shown in the blue dots, the red representing on average the number of high tide flood days along the continental US. You can see it's starting to really take off, and that is the case when we look at it at local levels. So what are these risk categories? Minor, moderate, major, high tide flooding is what we're calling it at NOAA. They are calibrated to the Weather Service's thresholds empirically. They have calibrated heights on the tide gauges with local emergency managers as to when certain types of impacts will occur. Shown here is some snippets out of the Wakefield office for Norfolk, giving a representation of what sort of a minor, a moderate, and a major flood would look like, the amount of water, and then the associated communication to the public for that I have sort of truncated. But moderate is typically a risk to property, a serious risk to property. Major is a risk to lives. Both the moderate and major trigger coastal flood warnings more times than not, whereas the minors, what they used to do, the advisories, I know they're changing their watch warning sort of communication schemes, but usually disruptive. We used to call it nuisance flooding. We're calling it sort of high tide flooding across the board. But we are trying to use these metrics as best possible. I say calibrated to the Weather Service because it's not exactly one-to-one. They don't have gauges everywhere, and sometimes they vary in severity levels, but more or less represent our exposure, our vulnerabilities at the ground as it exists today. We are providing warning. We have some tools at the Ocean Service that are similar in lots of effects to what the Weather Service has with their Advanced Hydrological Prediction System, shown here for Annapolis, where I live, a few weeks ago, that have a 2-day forecast associated with it, real-time observations, the astronomical tidal component with these thresholds shown so folks can sort of visually see and take action as needed. This is not the official Weather Service site. There is no warning or watches or any real forecast or call to action by the Weather Service. This is just a Ocean Service rendition of it, but it's useful, let's say, for folks like myself getting a sort of a snapshot as to where the water's headed. Do I need to loosen dock lines down at the boat or so forth? Lucky to live near the water. When the water hits sort of what I call the minor high tide flood threshold, it's sort of more aligned to the Weather Service's moderate, whatever. The docks start to go into water, real first world problem here, but the water is going up to the storefronts downtown Annapolis. So definitely some impacts, definitely some consequences with water, and it really just goes to show that it's important to use thresholds that actually mean something to folks. So not only for weather response and preparation, but then as we speak climatologically, how things have been changing through time. And so in terms of a representation, we like to use probability densities 365 days per year underneath the shape of this curve. Oftentimes used as risk curves that you may or may not see. On the x-axis is the height of the water level above average high tide, mean high water, and the y-axis just says increasing probability, as sort of the Gaussian normal distribution, let's say, that we would all get graded under in high school or college exams. You hope C, sort of the central tendency, you hope the teacher had some leniency and made that a B for everyone, for instance, right? A few A's, a few F's, hopefully mostly in between. Through time, that shifts. This is daily highest water over 10-year periods. Continue to fast forward. At sea level rise, drop in where our infrastructure is today, and we see we're starting to run amok up against what we have laid into the ground. The fat part of those curve is getting closer and closer. Inches now matter. What I mean by that is whether or not sea level has been accelerating itself, the impacts are on a daily basis, number of days per year. You fit this as now a quadratic. So a lot of this is lead up as to where we're going and why it's so important to be able to characterize this. We know that it's accelerating around most of the United States. That curve just shown for Norfolk, if it's red, it means it's similar. Yellow would mean just a linear statistical fit at this point. And because of that, we can extend these curves out and start giving some sort of outlooks, also based upon El Niño, La Niña characterization that gets factored in. We can even project out based upon the sea level scenarios that I showed earlier, to give perspective and to give folks a sense of what to expect next year for budgeting and planning purposes. But the new part, and what I'll show in the last few slides, is that we are now starting to map these three layers with the sea level rise viewer group. The inundation mapping show that minor, moderate, major around the country, shown here snapshots for Charleston, West Palm Beach. Gave a talk recently in Tampa. So it's close to the 2, 3, and 4 foot contours. However, it varies around the country due to tide range, due to the way that we have defined these minor, moderate, major based on calibration of the Weather Service thresholds. But one now might, and this is the part of the report where we don't have a tide gauge everywhere, but we need this kind of information everywhere. What is the probability of exceeding that kind of height around the country? And so what we have done is a regional frequency analysis, a statistical approach, very similar in nature to what they do for rainfall with Atlas 14, where you, from a local perspective, you have a regional risk perspective, but you localize that. So whether one tide gauge or a gauge measured it or not, if a nearby one did, how's your risk any different? You normalize these and statistically lump them together. In short, if you fall within one of these grids, we can recover exact statistics at the tide gauge shown in the dot, or there are downscaling localization schemes anywhere in one of these grids that we can now provide based upon either a short record. If you have 1 or 2 years of record, we can now localize that with that, or simple tide range information, which we can get from tide predictions that we have, let's say, at NOAA's VDatum, Vertical Datum Transformation Tool. The error or the uncertainty of the extreme probabilities themselves will inflate some due to this, but that's getting into the weeds. Nonetheless, we can now start to graduate FEMA's flood plain. We know it's not binary, it's not the same risk in and out. That's not necessarily the goal, but we are working with FEMA to help extend their risk curves down to the very high frequency part of the distribution. And so what that looks like, shown here on the x-axis, would be a typical risk curve, an average recurrence interval, if you will, like what is your 100-year event out of the 100? Though we should really speak to that as in terms of the 1% annual chance, the 10-year event, or the 10% annual chance, the 1-year event, all the way to the 0.1-year event or 10 events per year. We now have a curve to represent what that is based upon these regional sets of tide gauges, shown here localized for Tampa Bay, overlaying with the FEMA probabilities themselves that they have generated through synthetic storm sampling and other methods, largely based upon what the Army Corps of Engineers does today, knowing that they will not be the same. The 1%, the rare event, is a science in itself, but we can give actionable information. And as mentioned, we are working with FEMA to help sort of define that 1 to 10 year space. The FEMA shown here is with the wave component removed. The tide gauge obviously does not have wave run up, so we're trying to compare apples and apples and working with FEMA contractors to get this data. So in essence, we can develop one of these curves really anywhere along the United States shoreline now. And what the assumption is as sea levels rise, we will shift this curve accordingly, meaning we're not going to try to characterize changes in storm frequency or intensity, tide range changes. We're going to hold the variability part fixed as current science is really actionable. It's not, we don't really have guidance as to how to factor in at a local level besides adding, let's say, synthetic storms or rolling the dice many more times than we have under current environment. But sea level is driving a change. Now let's do just that. So let's look out 30 years with that type of risk curve and show how that is likely to change in the next 30 years if we don't do anything about it. And what we say here is a flood regime shift, because on average, the flood categories themselves are about a foot apart, and if sea level is expected to rise about a foot on average across the country, what is minor flooding will become moderate flooding become major flooding in terms of magnitude, or the frequencies of them will shift. And I'll show you that in a moment. So on average, shown here in the boxes, if the left column is 2020, that is the probability of the minor, moderate, major on average. And then we shift to 2050 based upon the regional, local expected amount of sea level rise. And what we see is the moderate flooding starts to occur more often than the minor does today. And the major starts to occur at almost the same rate as the moderate. So the sunny day flooding, the kind of events we're experiencing now, those will become a foot deeper and a slightly more frequent on average. So without change, you know, a flood is only a flood if it floods, right? Otherwise, just a high water and it's not damaging or impacting. So, you know, that's what our future holds, and that's what we're trying to convey, and at least give information not to scare folks, but to help prepare folks for what's coming if they do not take this information seriously and start planning at least towards this in the next 30 years, but hopefully beyond, because sea level rise is not stopping at 2050. So just the second to last slide in closing, you know, what does that moderate flood look like in Norfolk? Shown here would be a photo snapped on the day that the tide gauge was about at that moderate level, about 3 feet above high tide. This is you know, consequential flooding. The water is about 8 inches or deeper at the crown of the road, entering in the Norfolk Naval Base. Talking with some of the leaders there, that is a problem. That is preventing folks from accessing the base in proper manner, and that's a problem, not only to the military, but obviously the community. Then 1990, sea levels were lower. This type of event would have had about a 20% annual chance. It took much more of a storm, a brush of a hurricane perhaps, or a strong nor'easter. Now we have about an event per year. And in fact, that was probably pretty close just to yesterday and today down in Norfolk. Not quite that high, but we're getting there. It might have, I need to actually look to see how high that actual water got. Right, but it's just becoming a garden variety of reasons why we're hitting these types of levels due to decades of sea level rise. So in our headlights in 30 years, that grows to 5 to 10 events per year. An event oftentimes would last 2 days. So the translation between an event per year and days per year is about 2 days on average around the country. A nor'easter impacts day and a half, 2 days. So that's the news. It's not great, but it's important to know so folks can be prepared. So summary points, you know, the 2022 report really is the authoritative set of sea level rise information from the U.S. We're working with produced by the agencies, for the agencies, the consumer sides of the agencies who need this information, the military, the Army Corps, EPA, Department of Transportation, and others, as well as states and communities. We're headed for about a foot higher on average the next 30 years, and likely at least another foot on top of that by 2100 under the current trajectory. It could be higher, it's probably not much lower. That would be an average amount of sea level rise. Lower emissions equals less likely chance of higher sea levels. So lower emissions, lower sea levels. And you know, when we give this talk to, you know, down in Florida to others, it's not a policy statement, it's a scientific statement. Without action, we are headed for a flood regime shift, because a foot of rise with about a foot separating the severity levels on average around the country doesn't bode well for communities in harmed way, especially those that are not taking the upgrade, taking the, getting their plans rolling now, because it oftentimes takes decades to get things implemented. Plain and simple, elevation matters. Lower elevations are at a greater risk. When we transition from storm surge flooding into a tidal flooding regime, much more bathtub-like, it's pressure everywhere where the tide is, and it's less directionally oriented due to a storm. It just becomes everywhere. Lower elevations are at greater risk. And this really doesn't speak at all to heavier rain, stronger storms, or rising groundwater tables that are also a compounding factor. This is a tide gauge type perspective, so there's lots of reasons folks flood, and they are typically working together. Same things causing the oceans to rise: heating, producing stronger rains, heavier rains, stronger storms, and that's affecting groundwater too. So unfortunately, there's a lot of variables working together that we will continue to explore and try to quantify and put out information with this task force as we move forward. And with that, I'll take questions if there's time. Here's a new site we have at the Ocean Service that kind of bundles a lot of things about the sea level rise report itself, as well as all the other tools related across NOAA and the other agencies. And working with NASA, they also are supplying the data from the report itself in a really neat website. Colleague Ben Hamilton, if you have questions for NASA side, please reach out to him. And if you have questions on the NOAA side, feel free to email myself. All right, well, thank you.
Really, thank you. That was tremendous. There's so much effort that went into these reports and these tools to, in particular, regarding the impacts at regional and community levels. And I'm just really proud of all that you and your team have done. This is so incredibly important to the East and Gulf coastline. So thank you. We have about 10 minutes, a little bit less. We have a series of questions, not surprising. Billy, I've started to put them into a chat that you should be able to see. I'll start going through those right now. Before I do that, and then perhaps if you could stay on for a little bit longer and folks want to stay on for a few minutes, we can get to as many questions as we can. Just a reminder that the next webinar, we're changing our time. We're now moving webinars to the 4th Tuesday of the month. So the next one will be June 28th. There'll be a registration link in the webinar recap that will go out hopefully by the end of today, and that will be the hurricane outlook. So please join us. And as a reminder, there's always a quick survey that comes up at the end of the webinar. If you haven't taken it and you have some suggestions on other special topics you would like to hear about, please let us know. Okay, so I'm going to go ahead and start right now for our first question. These are all for Billy. The first one is, since all land elevations and topographic contours are based upon height above mean sea level, with the sea level rising, when do we need to update all the topographic maps and base elevations of land survey markers?
Well, there are two updates coming. Right there is the next tidal data epic update, which the data informing that has ended, but the publishing of those benchmarks won't be available until 2024 and 2025. So that'll help establish a new tidal datum. And then GravD, I guess, for the geodetic survey, will be updating their geodetic datum side, as best I understand, in the next couple of years as well. So there'll be some new datums that will definitely be coming online, so that there'll be new numbers assigned to a lot of these benchmarks, so folks have a better idea of ultimately, I guess, the goal in a changing interface with the ocean is to get that offset correctly. What is the height above the average tide at that temporal time frame? And we do this on a 19-year basis now. With sea levels continue to rise and accelerate, I will have to see about that update schedule. That might become a little bit lagged in time, but I would say in the next few years, you're going to see some new numbers, which should provide a more contemporary snapshot of the elevations of lands as they are relative to the tidal surface.
Great. Next question is related to Atlantic circulation. Does the overturning circulation in the Atlantic figure into sea level rise along the U.S. East Coast?
Yes, it does. It's not only the speed or the transport, as the transport slows periodically, which it does, a northerly wind will actually counteract the Gulf Stream, as well as having secondary sort of Ekman transport along the shoreline. A lot of scientific jargon here. In short, when the Gulf Stream slows, you have higher sea levels along much of the East Coast, at least south of Hatteras, but it's also the amount, it's the temperature of the water that it's carrying as well. So in the last 4, 5, 6 years, there has been warmer water in the Gulf Stream, not necessarily a clear, discernible slowdown of the Gulf Stream trend, though that is still being debated, but the water has been warmer, and that's where we're seeing a lot of higher sea levels in areas of the Gulf and southeastern United States. There's been definitely an uptick in the last 4 or 5 years, and that's been attributed in the science as to higher overall temperatures of the water itself. Warmer water occupies more volume than colder water. But all the models suggest in a warming environment, continuing fresh melts of Greenland in the north, that we would expect a slowdown or a reduction in overturning circulation, which would exacerbate the amount of rise projected to occur along the East Coast United States.
Great. The next question is, what impact on sea level rise might result from reversing the long-term trend of transfer of terrestrial waters to ocean? Doing so is crucial for maintaining food security.
Sure. So there have been episodes in the past of dam building in the 50s, which actually caused sea levels to not rise as much as they would. There was a bit of a reduction in the rise amounts. Conversely, with the pumping of groundwater, we're seeing that now as a small contribution to the overall budget of sea level rise, which is largely at this point 2 parts land-based ice, Antarctic, Greenland, mountain glaciers, 1 part thermal expansion, with a third contribution from changes in land storage, which is much less significant in its overall impact, though it is not non-trivial. It is a contributor. So as long as we continue to pump groundwater, well, we lose that fresh water in the system, but it also will add some to overall sea level rise amounts.
Okay, great. Billy, just want to check, can you stay on for a few more minutes?
Sure.
We have 140 people still on, so if we could get through a couple more questions, that would be great. Thank you.
Absolutely.
Okay, our next question is related to impacts, specifically on development. Has any impact of development been considered? For example, less impervious surface?
Yeah, there definitely have been studies in the National Climate Assessment ongoing now. You know, we're trying to pull together the types of studies focusing on, those types of characteristics. What are some strategies for being resilient in terms of sea level rise, coastal flooding, rain flooding, you name it. We know that less impervious surface definitely slows the water and would help with things like rain. In terms of storm surge, we know that green barriers will actually slow the surge. In terms of tidal flooding, again, that becomes more elevation. You're not really setting up green infrastructure to hold back the tide, but you perhaps will let land sort of go back to its normal self and get development out of the way of these areas that are starting to flood more often. But impervious surface is definitely not helping the stormwater design that, let's say, was built on standards 50 years ago. Perhaps there was some forward looking saying we're going to build in X amount of increase in impervious surface, but as high tide floodwaters start to back through these stormwater systems, we're starting to see a serious degradation in stormwater capacity along many of important systems and cities along the United States coastline.
Okay, next is more of just a comment related to your Norfolk slide, which was incredibly powerful. Just saying that the recent flood in Norfolk got there, according to where you were projecting it would go. 3 days of near moderate flooding in Norfolk, higher in the tributaries. So really compelling. The next question is related to differences between geographies, Gulf of Mexico. So why is sea level rise the greatest in the Gulf of Mexico coastal section as compared to other U.S. coastlines?
Currently, it's largely due to vertical land motion, land subsidence in the Mississippi River Delta area, as well as very large extraction rates ongoing in areas of Texas. We know it's the capital of at least the United States in terms of petrochemical. There's a lot of on-site extraction, which also use of groundwater. That's largely the reason for the large, both natural and unnatural reasons in, let's say, the northern and western Gulf. The central, or the eastern, excuse me, it's been similar in lots of ways to the southeast United States right now, with the definitely uptick in heating of there's a lot of warm water down there, and it's accumulating, has been causing rates to rise over the last, let's say, decade, higher rates. So when we look at long-term trends, which are beginning to become a little bit outdated, we're no longer, or the suggestion is, let's not fit 80, 100-year linear trends any longer if they're not linear over the last 4 or 5 decades. But we definitely still see some high rates along the East Coast, but overall the Gulf is higher, largely for that land subsidence reason.
We only have a couple more left. One question is if we can have a copy of the presentation. Just a reminder, we're going to be sending out a recap email with a link to the YouTube recording, as well as contact information for the presenter, William Sweet. So if you'd like a copy of the presentation, please reach out to Billy, if that's okay with you.
Sure.
Okay. And next question, 2 more left. Do you remember a coastal storm in the past that retrogressed in May or June and then entered the southeast U.S. a few days later?
I don't necessarily. I bet Jeff Auroch's on the line somewhere. I bet he does. I try to track them, and that's largely because I'm a citizen too, and I kind of pay attention to what's happening. But so a lot of the individual events, sort of come and go, and I'm not necessarily tracking them individually as closely as some others in the weather forecasting world.
Great. Do any of our other panelists like to respond to that question? I know that's a great question, I think, for next webinar. Okay, then our last question is, how is strength of storms tracked, especially for early data? Again, this is getting more into storms.
Yeah, and that's a little bit outside my expertise. There have been, I know, with the Northeast Climate Hub, that is, correct me, it's somewhere up there, and probably some of you are on the phone. I know there's definitely been a storm tracking, the low intensities, whether you're tracking the storms, atmospheric pressure or wind speeds. From a tide gauge perspective, that can be a little bit difficult as a lot of things superimpose into the signal. So that is a difficult one, and I think it's generally done with atmospheric parameters, wind speeds and atmospheric pressure. But there is an indication of the surge component and the non-tidal residual, which is the non-tidal part of the tide gauge itself. Above thresholds, we can definitely start setting certain heights that will definitely capture the more intense storms. But again, as sea levels continue to kick up, we're starting to find relatively normal events, blowing 20, 25, but with sea levels hitting heights that used to require, more localized strong storms, perhaps even hurricane brushes 50 years ago. So the water levels themselves become less informative unless you compensate for the amount of rise that's occurred and normalize in that fashion. But that's still sort of a science and data technique heavy method that isn't necessarily one size fits all for characterizing storm strength.
Great. And Billy, I know that I said there's only one more question, that was it, but I do have one more question. I think it's an interesting one. I also have a response to the earlier question about a coastal storm that retrogressed in May or June and entered the southeast later. Someone suggested Hurricane Beryl in 2012. Okay, last question, I promise. Do we have estimates for sea level rise from the 17th to 19th centuries, trying to compare with the older infrastructure, for example, in St. Augustine?
You know, back then, we really didn't have many, we didn't have US tide gauges. The earliest US tide gauges came online in the 1890s. So we would have global reconstructions that would go back to those time periods, obviously with a lot of uncertainty, much larger uncertainty. So it's harder to really put into context at a local level. But I could, if someone emails me, I could point to some of these longer reconstructions, and oftentimes they overlap with marsh grass dating that can go back thousands of years, but then can go all the way back to 100 years ago or so, or even closer, that have aligned with the tide gauge based estimates. So there, again, larger uncertainties, but there are global reconstructions that go back hundreds of years as well as thousands of years, of course.
Billy, that was fantastic. You just covered a lot of pretty intense questions in a short time, and you covered it really well. I'd like to once again, on behalf of the National Weather Service, the Southeast Regional Climate Center, and NIDIS, the National Integrated Drought Information System, we three host this webinar series. We thank you for joining us today. We're very grateful for the presenters. If you have any questions, please don't hesitate to reach out, and have a wonderful day. And thank you for over 100 people sticking around to nearly 10 minutes after the hour. Thank you again. Bye-bye.